Discussing the topic of center of mass. So we have this wire which is bent in the form such that at the center of this arc this subtends an angle 2 alpha. This is a linear body and we have to find the center of mass of this wire. So for this again we will take a small element of this. AB is the wire, O is the center, so we take O as the origin and this small element of this is selected, joining this with the center. This is subtending an angle d theta at the center, and the angle made with the x-axis is theta. So we have this as the x-axis and this is the y-axis. It is symmetrical about x-axis, that means center of mass will be lying on x-axis only. Y coordinate will be at the origin. So now we have to find its center of mass, and that its mass density is lambda. So dm, mass of small element, is r d theta, where r is the radius. R into this angle, the length of this small element is r d theta. You can assume this to be almost linear. So if you find the center of mass of this small element, then you can find by integration the center of mass of this whole element. The mass density is assumed to be uniform. So if I draw from this point a perpendicular on the x-axis, then center of mass of the small element will be at its center, but its thickness is so small, that is d theta is so small, so r theta is even smaller, that distance of this point from this point is very small, and we can take distance of center of mass from the x-axis as distance of this point from the x-axis. Now what is this distance? This is equal to r cos theta, and this distance is r sin theta, r cos theta, and here this distance is r cos theta. Now we can find the x coordinate of center of mass. So x coordinate I can write as integral of x dm divided by integral of dm. So dm, we know that this is equal to r d theta here multiplied by lambda. Lambda is assumed to be constant, so x r d theta lambda by integral r d theta lambda. Lambda is a constant, can be taken out. Now what is x? This distance from the y-axis of the center of mass coordinate of this small element, so this is r cos theta. So r cos theta into r d theta lambda divided by r d theta lambda. Lambda cancels out. Theta is a variable varying from minus alpha to plus alpha. So r is also a constant, so r square cos theta d theta minus alpha to alpha by r d theta minus alpha to alpha. So this is r sin theta minus alpha to alpha divided by theta minus alpha to alpha. So we get r sin alpha 2r sin alpha divided by 2 alpha. So xc is equal to r sin alpha divided by alpha. So if you have a wire which is subtending an angle, say 2 alpha, equal to 90 degree at the center. 2 alpha is 90, So alpha is 45 or pi by 4. In that case, xc, if the wire is in this position, if it is in vertical position, then we will find the y coordinate. So xc is r sin alpha, r sin pi by 4 divided by pi by 4. So this is 4r divided by pi into 1 by root 2. So 2 root 2 by pi r. So this is how you can find the coordinate of center of mass of such a wire. Y coordinate will be 0. So after this, in next discussion, we will be discussing the center of mass coordinates, how to find them for the planar bodies.